All right, so this is pre-calculus lesson 4.6, day 1. And we're looking at tangent and cotangent graphs. A big change is that there is a period change. The period for tangent and cotangent is pi. So for tangent, the period is pi. For cotangent, the period is pi. And then you have asymptotes for tangent at plus or minus pi halves. And that goes back to the unit circle, the quadrantal angles right here. The point on the unit circle is 0, 1. And right here it is 0, negative 1. And so tangent of pi halves, since it's defined to be y over x, you get 1 over 0, and it is undefined. Same thing at tangent if you rotate to negative pi halves. Your y over x is negative 1 over 0, and that is undefined. And so when it's undefined, you actually get a vertical asymptote because there is no x value. Those x values, there is no output. So that's where you get a vertical asymptote. And then for cotangent, you have asymptotes at 0 and pi. Because at 0 you have 1, 0, at pi you have negative 1, 0, 4 on the unit circle. And the cotangent of 0, it is x over y, and x is 1, and y is 0, and it is undefined. And at cotangent of pi, again, you have x over y, and x is negative 1, and y is 0, and that is undefined. So for cotangent, you get asymptotes at 0 and at pi. And that's going to play into what their graphs look like. So we have the standard form here, y is equal to a tangent bx, and y is equal to a cotangent of bx. And there isn't an amplitude on tangent or cotangent because the range on tangent and cotangent is all reals. It goes from negative infinity to infinity. Unlike sine and cosine where you get it fixed between negative 1 and 1, amplitude, there has to be a ceiling and a floor. So there isn't an amplitude for tangent and cotangent, but there are vertical stretches and shrinks. And A does that. It does a vertical stretch or a vertical shrink. And then Bx affects the period. And the period is going to be pi divided by B. Because tangent and cotangent's period is only pi, the period is going to be pi divided by B. So, and then we'll get to C a little bit later, but we're not going to work with that today. So let's look at the basic footprint of the tangent of x. And if we go to the unit circle, and at 0, we have 1, 0. At pi fourths, we have root 2 over 2, root 2 over 2. At pi halves, we have 0, 1. We can start doing the tangent is the ratio of y to x. So the tangent of 0 is y over x, and that is 0. The tangent at pi fourths is root 2 over 2, root 2 over 2, and the tangent at pi fourths is 1. And the tangent at pi halves is your y over your x, and that is undefined, and that's where you're going to get a vertical asymptote. If we go to pi, you have negative 1 over 0, and the tangent of pi being y over x is 0. And at 3 pi halves, it's going to be undefined. And 3 pi halves is the same as negative pi halves. 3 pi halves goes all the way to here. Negative pi halves goes to here. It's the same one. And you get 0 in the denominator, and it is undefined. And negative pi is the same as pi. From here to here is pi. Going this way, it's pi, and at pi, tangent is 0. So I'm going to grid this by pi fourths. The period of tangent is pi, and so the key increment is still going to be 1/4 of the period like we did with sine and cosine. And that's what I want to grid the graph out as. Pi fourths, this will be pi halves. This will be 3 pi fourths. Then we would have pi and 5 pi fourths. 3 pi halves. And then you are at 7 pi fourths. And then we are at 2 pi. And to the left, negative pi fourths, negative pi halves. And we're just going to stop with that. And so if we go to plotting these points at 0, tangent is 0. At pi fourths, tangent is 1. At pi halves, you have a vertical asymptote because it's undefined. 3 pi fourths, we didn't talk about it, but 3 pi fourths tangent is negative 1. It would be over in quadrant 2, and you'd have a negative root 2 over 2, root 2 over 2 on the unit circle, and the ratio of y to x will be negative 1. So at 3 pi fourths, tangent is negative 1. These are values that you should be able to use the unit circle to evaluate with. And at pi, we looked at that in the chart, it's 0. In 5 pi fourths, that is quadrant 3, all students take calculus, tangent's positive there, and tangent is positive 1 at 5 pi fourths. At 3 pi fourths, we have another vertical asymptote. 7 pi fourths, 45-degree reference angle. It is quadrant 4. Tangent's negative there. It will be negative 1. And at 2 pi, you're really back at 0. Typically with tangent, we go to the left of 0. And at negative pi fourths, that's the same as 7 pi fourths. You're at negative 1. And at negative pi halves, same as 3 pi halves, you have a vertical asymptote. Now, you don't want to just connect the dots and have them look like a straight line between those 3 points. It looks a little bit more like a cubic function. And so it stays a little bit closer, and then it starts going down. And then it should just run parallel to the vertical asymptote because it's not going to ever touch the vertical asymptote or cross it. So it's concave down on that. And then to the right, it's concave up. And then it's just going to end up it gets physically closer and closer to the vertical asymptote, but it never touches it and never crosses it. And that is the footprint of one period of tangent. From negative pi halves to pi halves, that is a distance of pi. And that pattern just gets repeated over and over and over again. And so here's another footprint of the period of tangent. And here's half of a footprint. But it's so, I hope that you understand that tangent and cotangent, 45-degree reference angles are 1 or negative 1 because you get that plus or minus root 2 over 2, root 2 over 2. So tangent and cotangent are 1 or negative 1 at 45-degree reference angles. So now, cotangent is the reciprocal. So every time you have where tangent is 0, that is going to be where cotangent is undefined. Because cotangent's not y over x, it's x over y. And so if we look at these quadrantal angles on the unit circle, the cotangent of 0 is your x over your y, which is 1 over 0. It is undefined. The cotangent of pi halves, your 90 degree, your x over your y, is 0 over 1, which is 0. So at pi halves, it is 0. The cotangent of pi, since it's x over y, is going to be negative 1 over 0, and that is undefined. And then the cotangent of 3 pi halves, again, x over y, is 0 over negative 1, and that is 0. So tangent and cotangent flip, where one's 0, the other's undefined, and vice versa, because of flipping x and y. And then at your 45 degrees, cotangent's going to be 1. At 3 pi fourths, cotangent's going to be negative 1. At 5 pi fourths, cotangent's going to be positive 1. All students take calculus, the third quadrant, because both x and y are negative, the ratio is positive. And then at 7 pi fourths, cotangent's going to be negative 1. The values of tangent and cotangent at pi fourths, 3 pi fourths, 5 pi fourths, 7 pi fourths agree. They are the same values. And so at pi fourths, cotangent is positive 1. I think that this is supposed to be a negative pi halves, because we already have pi halves. Negative pi halves is the same as 3 pi halves. It's x over y, 0 over negative 1 is 0. And remember from the previous graph, at negative pi halves, the tangent was undefined, so we expect cotangent at negative pi halves to be 0. At negative pi, it's x over y, negative 1 over 0 is undefined. It's the same as pi for cotangent, so it is undefined there. And like tangent, the period is pi, and the key increment, you divide it by 4. And that's what we want to grid this out as. So we have pi fourths, pi halves, 3 pi fourths, pi, 5 pi fourths, 3 pi halves, 7 pi fourths, and 2 pi. Cotangent at 0 is undefined. It's x over y, you get 0 in the denominator, so you have an asymptote on the y-axis. At pi fourths, cotangent of pi fourths is going to be 1. Because you get a ratio of root 2 over 2 over root 2 over 2. The ratio is 1. So cotangent is 1 at pi fourths. It is 0 at pi halves. And at 3 pi fourths, quadrant 2, it's negative 1. Cotangent's negative in quadrant 2. And at pi, it is undefined again. At pi, it's undefined. you get 0 in the denominator, so we have another vertical asymptote at pi. And then that pattern repeats because 5 pi fourths is quadrant 3 and cotangent's positive there. 3 pi halves, cotangent 0. 7 pi fourths, cotangent's -1. And at 2 pi, it's the same as at 0. We have another vertical asymptote. And so cotangent is an overall decreasing function. And again, it's going to look like an x cubed where it changes from concave up to concave down at that 0. And so that's one complete footprint of cotangent. Length of that is pi. And that pattern just repeats, 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 repeats. And so here's another full period of cotangent. Notice that overall tangent, as you're going from left to right, you have to pick up your pencil at the asymptotes and move across, but you go up, up, up. It's an increasing function. Cotangent, starting from left to right, you are going down, 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 pick up your pencil, start here, you're going down, down. Cotangent is an overall decreasing function. So let's look at some amplitude, some vertical stretches and some periods in here. And so on A and B, they only ask you on the back here, what is the period? And the period is pi divided by B. I find myself messing it up once in a while and just not, if I'm not in the game thinking. You've got to switch. Sine and cosine periods are 2 pi. Tangent, cotangent, periods pi. And so the A value here is 3, the B value is 2, so the period is pi divided by 2. In part B, you need to make use of structure and understand that this is the same as 1/6 times x. So B is 1/6. So the period is pi divided by 1/6. And when you divide, you multiply by the reciprocal, and the period is 6 pi. These are horizontal stretches and shrinks. When you have a number times x inside the functions that's greater than 1, you get a horizontal shrink, which is going to shorten the period. So it goes from pi to pi halves. When you have a number times x inside between 0 and 1, you get a horizontal stretch, which will lengthen the period. Notice that instead of the period being pi, it's 6 pi. So it corresponds with horizontal stretches and shrinks. All right, so graph over 2 periods. The period for this is pi divided by 2. This is your B value. And then your key increment is 1/4 of pi halves. And so now your key increment is pi eighths. With tangent, two key increments to the left. There is an asymptote. And 2 key increments to the right. There is an asymptote. They correspond with what was negative pi halves and positive pi halves, but they aren't those anymore because we've shrunk the period. And so when I find the key increment, 2 key increments to the left, negative pi eighths, and then this is a negative 2 pi eighths. For tangent, there is going to be an asymptote. And 2 key increments to the right, pi eighths, 2 pi eighths. There is another asymptote. And 1 key increment to the left, you're going to be at -1. That corresponds to what was your 45 degree in quadrant 4. At 0, you are still at 0. Okay, I have to go back and change this. You would be at -1 if there hadn't been a vertical stretch of 2. So you would normally be at -1, but you have a vertical stretch of 2, so you end up being at -2. And 1 key increment to the right, you would normally be at 1, but because of the vertical stretch, you end up at 2. And then try to emphasize that there's a change in concavity. It's concave down, it changes to concave up. And that is 1 footprint. From here to here is pi halves. This is pi fourths to the left, pi fourths to the right. That adds up to pi halves. That is your length of your period. They want this for 2 periods, so you're just going to keep on going and do the same footprint. 3 pi eighths, 4 pi eighths, 5 pi eighths, and 6 pi eighths. And you're going to go from -2 to 0 to +2, and you will have another asymptote. So your equations of your asymptotes, they are vertical lines. And so I've got it at x is -2 pi eighths, but I wouldn't leave it that way. I would write it negative pi fourths, simplify it. And then we have 2 pi eighths, which is positive pi fourths. And then we have 6 pi eighths, which is 3 pi fourths. And the distance between those asymptotes better be the length of the period. And it is. And then lastly, you have your zeros. And they are at 0 and at 4 pi eighths, which is pi halves. Your x-intercepts. All right, so let's look at 3 cotangent. And for this, making use of structure, you want to think of it as 1/2 x. So that coefficient of x is between 0 and 1. I expect the period to lengthen. And the period is pi divided by 1/2. And when you divide by 1/2, you multiply by its reciprocal. And so its period is 2 pi. And so then the key increment, you take 2 pi and divide it by 4. And the key increment's going to be pi halves. But with cotangent, you start with an asymptote on the y-axis. Because where tangent is 0, cotangent's undefined. So start with an asymptote on the x-axis. and then use your key increment and just go to the right. So I'm just adding by the key increment. 1 pi half, 2 pi halves, which is just pi, 3 pi halves, and then you get 4 pi halves, which is your 2 pi, which is your length of your period. So 4 key increments to your right, you will have another asymptote. But remember, cotangent decreases. All trig functions are positive in quadrant 1. So where I'm going with this is we have a vertical stretch by 3. You start up at 3 because that's really equivalent to being in the first quadrant, but you've done a horizontal stretch to it. So cotangent starts at positive 3 here, then it goes to 0, and then it goes to negative 3. The 3 and the negative 3 correspond to what used to be 45-degree reference angles before the horizontal stretch. And so it's kind of coming steeply. We have this change in concavity. And then it follows the asymptotes. And for one more period, you just keep on going. We have 5 pi halves, 6 pi halves, and you're welcome to reduce those, but I don't really care in terms of how you grid this out. And so 4 key increments beyond that, you have another asymptote, and then it goes 3, 0, negative 3, and you have another footprint. So the equations of the asymptotes are x equals 0, and then it is 4 pi halves, which is 2 pi, and then it's 8 pi halves, which is 4 pi. The distance between them is the length of the period. They're going by 2 pi's. And then your x-intercepts, or your zeros, are at pi and three pi, not 3 pi halves. I looked at the wrong one. Sorry. Because they also will have a distance between them of the period. Okay, so in example 4, y equals negative 3 cotangent x, pi x. Well, because this is negative, you're going to get a flip. Your period is going to change, but with cotangent, since there's no shift right or left, we're not doing that, or up or down, you're still going to have an asymptote, and then you're going to go the length of the period to the right, divide that into fourths, which is why we do key increments by period divided by 4, and then it will start at negative 3, go to 0, and go to positive 3. Because it's flipped, because it's negative. So it changes from decreasing to increasing. You want to go, okay, there's no shift right or left, it's cotangent, you start with an asymptote on the y-axis. So looking at that, the period is, there you go, pi divided by b is pi. And so the period is 1. And then the key increment is 1/4 of that. So the key increment is 1/4. And so on the graph, I would be going 1/4, 2/4, 3/4, and then 4/4, which is 1. And then the y-axis, since there's no shift right or left, is an asymptote. When you get to that fourth key increment, which is the length of the period, there will be another asymptote. Halfway in between them is your 0. Halfway in between them is the 0, but normally it would be up at +3, but since it's negative, it's going to be down at -3. And again, we want to emphasize that change in concavity. So kind of have it go a little bit flat right there and then curve up. And then have it appear that it's going to kind of run parallel to your asymptotes. And then repeat that. You're at 1, which is 4 pi-fourths, so you're 5/4, not pi, but just 5/4, 6/4, 7/4, and 8/4 would be at 2. And you will have another asymptote at 2. And that -3, 0, and 3 just keep on repeating. So your equations of the asymptotes are x equals 0, x equals 1, and x equals 2. And your x-intercepts are going to be at 1/2 and 3/2. Again, the distance between the asymptotes better be the length of the period. The distance between the zeros better be the length of the period. And your assignment for today is a worksheet.